question 5. The curve has an equation y is equals to 4x cube plus 2 over x plus 9, where x is greater than 0. Find dy by dx. Giving your answer in simplest form. Given that, okay, fine. So this is just simply we need to find the derivative of y with respect to x. So the curve equation is y is equals to 4x cube plus 2 over x plus 9. Okay, so as for we do for the integration, we do it for the derivative as well. We cannot take the derivative or integral for a variable in the denominator. So first we arrange it and shift it to the numerator. So it becomes 4x cube plus 2x to the power minus 1 plus 9. Now we'll take the derivative. Dy by dx will be then equals to, okay, what is the formula for the derivative in general? Derivative of any function x to the power n would be nx n minus 1. Okay, so we will be applying that here. So the derivative of x cube would be, 4 is the constant, so we'll keep it outside, 3x square, nx n minus 1, so 3 is n power, so nx 3 minus 1 is 2, plus 2 times n x n minus 1, so it becomes minus 1 x to the power minus 2, okay, plus 0, because the derivative of any constant number is 0, so plus 0. So arranging it just, so 4 3 times is 12, 12x square minus 2x to the power minus 2. Again we will be, now we can again shift it to the denominator because the power is negative, so the simplest form is to keep it in the positive power. So this is your final answer for the derivative. Now there is part B to it. Part B says, given that the point P lies on curve C, okay, what kind of a curve will it be? It will be a curve like this because it's a cubic curve. They say the point P lies on C. So let's say any point P lies, P is this point, okay, and just one more try to make it to, yeah, let's see, point P is here and the tangent is on the point P, and the line of the equation of the tangent is k minus 5x, where k is constant, is tangent to C at P. Show that the x coordinate of P satisfies the equation. Okay, if we just will be able to form an equation 12x4 plus 5x square minus 2, so that means x coordinate satisfies the equation. So what do we know from the equation of the tangent? That the slope of the tangent is minus 5. Okay, also in part A we found dy by dx. The dy by dx at P should be equals to minus 5. Okay, so that means that this expression, the general expression for the tangent, as the tangent lies on the point P, this should be equals to minus 5. Okay, because the equation of the tangent is this, and we know that this tangent lies on point P, so it must satisfy, and it should give you, it must satisfy the x coordinate of the point P, and it should be equals to minus 5. So if we will be able to find out that, make out that equation, then it means that x coordinate satisfies this. So let's multiply the whole equation by x square, so as to simplify it, multiplying by x square. So it will be minus 5x square equals 12x4 minus 2 again 12x to the power 4 plus 5x square minus 2 equals 0, and this is what we needed to prove. 12x4 plus 5x square minus 2 equals to 0. Hence find the value of k. So how can we find the value of k? We should be having x and y of point P so as to calculate k, and for that reason we should be finding x first and then y. So as we know that 12x4 plus 5x square minus 2 is equals to 0, this is a quadratic equation. This is what do we call it? Disguised quadratic equation. Like it, yes, there is a maximum power 4, but as you can see in quadratic, what is a quadratic? In which you have x square term, then half of the power of x, and then a constant term. So same appears to be here. We have x4, then half of the power x square, and then a constant term. So we can solve it as it is, or we can put this x square equals to a or some other constant and then solve it. So what should we be having? 12x4, 12 2 times 24. What seems to be that we should be having two numbers that when multiplied should give you 24, and when added or subtracted should give you 5. So when subtracted gives you 5. 8 and 3. 8 minus 3 is 5, and 8 3 times is 24. Yeah, so we will be having, I'm not doing it by putting x square equals to a substitution. You can use that too. Okay, I'm doing it directly. So it will become 12x to the power 4 plus 8x square, 8x square minus 3x square minus 2 equals 0. Okay, we split this into two factors of 24. Okay, so we take 4x square common, 3x square plus 2 minus 1 common, we will be getting 3x square plus 2 equals 0. So it will become 4x square minus 1 and 3x square plus 2. So from here we will be getting x square is equals to 1 over 4, or x square is equals to minus 3 over 2. Okay, out of these we can decide for, like if we take square root for this, it will be a square root of minus 3 over 2. That is not going to give you any real solution, so reject it. For this one, x will be equals to, if we take square root on both sides, plus minus 1 over 2. Still out of this, as we know that x is greater than 0, so we will be taking it only. This implies x is equals to 1 over 2 as x is greater than 0. Okay, so this is your x value. What we needed to find? We needed to find the value of k. For that, I told you we need the coordinates, okay, of any point, and that point will be the point P. So now find the value of y. let's plug in this x value in the equation of y. 4x cubed plus 2 over x plus 9. So y will be equals to 4 times 1 over 2 cube plus 2 over 1 over 2 plus 9. So this becomes 4 over 8 plus 4 plus 9. This is 2 divided by 1 over 2, so that means 2 multiplied by 2 over 1. So 1 over 2 plus 13, 27 over 2 will be your y coordinate. Now we have the P point to be x is 1 over 2 and y is 27 over 2. Now we know y is equals to minus k minus 5x. So if we'll plug in x and y values, we will be getting k. So y is equals to k minus 5x. As so 27 over 2 equals k minus 5 times 1 over 2. So k equals 27 over 2 plus 5 over 2. So 32 over 2. So k appears to be equals to 16. Okay, so this is your whole working of your question 5.